Find the general solution to the ODE y double prime plus 4y prime plus 13y equals 0. So same thing as always, create the characteristic polynomial with our guess of y equals e to the rx. Alright, so the characteristic polynomial will end up being the 1 in front of the y double prime times r squared, it's just r squared, plus 4 times r, plus 13 times e to the rx equals 0. We have to factor this. I definitely can't do that in my head. Got to use the quadratic formula again. I usually have to use the quadratic formula when the roots are complex. So let's go ahead and do that. We've got a equals 1, b equals 4, c equals 13. Right, so negative b plus or minus square root b squared minus 4ac over 2a. Okay, well that ends up being negative b, so I have negative 4 plus or minus square root b squared, so that's going to be 16 minus, okay, I've got 4 times 1 times 13. Okay, 4 times 1 times 13. That sounds like 52. Yeah, I think that's right. And then over that is just 2. All right, then let's keep going. So I got negative 4 plus or minus square root. Okay, 16 minus 52. Pretty sure that's negative 36. Yeah, pretty sure. And then all that over 2. Okay, well that's the same thing as negative 4 plus or minus square root of 36 times square root of negative 1 over 2. All right, but that's negative 4 plus or minus square root of 36 is 6. Square root of negative 1 is I over 2. Okay, then that ends up being negative 2 plus or minus 3i. Alright, so again, so here we have our lambda equals negative 2 in our roots, and we have mu is equal to 3, right? This is lambda plus or minus I. Alright, again, so the general solution y of x equals c1 e to the lambda x cosine of mu x plus c2 e to the lambda x times sine of mu x. So plug in those numbers, we end up with c1 e to the negative 2x cosine of 3x plus c2 e to the negative 2x times sine of 3x. And that's it. We found the general solution. We're done. If you want, you could, take 2 derivatives of this. It gets pretty messy because you end up having product rule and then product rule again. But if you plug this into the original difference equation, it does satisfy the original.